The whisper begins, discovering the hidden language within everything. Have you ever wondered what happens in the spaces between your thoughts? In the quietness of night, when the world around you finally rests, something extraordinary continues its eternal conversation. Right now, in this very moment, billions upon billions of invisible entities are communicating in a language older than time itself. They are atoms, and they are speaking to each other within you, around you, through everything you touch, see, and breathe. Close your eyes for a moment. Breathe slowly. Feel the weight of your body against whatever surface holds you. That sensation, that tangible reality, is the result of an invisible symphony, playing at scales so small that human eyes will never witness it directly. Yet this symphony is as real as the ground beneath your feet, as constant as your heartbeat, as fundamental as existence itself. Before we begin this journey into the secret language of matter, I invite you to subscribe to the Relaxing Science channel. Give this video a like and share your location and the time of day with us below. These small gestures help us understand where our listeners are and what moments you choose for contemplation. This information shapes the future explorations we create together. Tonight, we will explore something that science has only recently begun to understand fully. We will move beyond textbooks and equations into the poetic reality of what atoms truly are. Not merely as particles in a physics classroom, but as ancient messengers that have traveled through billions of years, through countless transformations, carrying within them the memory of the universe itself. Every atom in your body has existed since the universe was born. Think about that for a moment. The calcium in your bones, the oxygen in your lungs, the carbon in your cells, the iron in your blood. All of these have journeyed through space, through dying stars, through the formation of planets, through the emergence of life itself. They have been part of dinosaurs, mountains, oceans, and countless beings. And now, in this precise moment, they are part of you, experiencing consciousness through your perspective. The atoms are not separate from you. They are not distant objects we observe from afar. They are the very substance of your being, the builders of your form, the architects of your thoughts. When you think a thought, atoms are communicating. When you feel an emotion, atoms are dancing. When you dream, atoms are creating entire universes within the landscape of your mind. Science has taught us to observe the physical world through measurement and mathematics. But there is another way to understand atoms, through contemplation, through metaphor, through the recognition that the boundary between observer and observed is far more blurred than we once believed. When we study atoms, we are not studying something separate from ourselves. We are studying ourselves, looking inward into the very foundation of our existence. Throughout this exploration, we will discover that atoms are not inert building blocks randomly assembled. They possess what we might call a language, a set of rules, preferences, and patterns that guide how they interact with one another. This language determines why water flows, why fire burns, why your body maintains its shape, why colors exist, why music resonates in your ears. Everything you experience is a translation of atomic communication into sensations your consciousness can interpret. The ancient philosophers spoke of a hidden order underlying reality. They called it logos, the universal principle. Modern science has revealed that this hidden order is quite literal. Atoms follow rules so precise, so consistent, that they allow us to predict and understand the behavior of all matter. Yet within this precision, there remains mystery. There remains silence. There remains space for wonder. As we move deeper into this exploration, you will begin to see the world differently. A stone will no longer be merely hard. It will become a crystalline conversation, frozen in geometric perfection. A flame will no longer be merely light and heat. It will become the visible expression of atoms releasing energy accumulated from the sun millions of years ago. Your own body will no longer be merely flesh. It will become a temporary arrangement of ancient cosmic materials, conscious of itself, able to reflect upon its own existence. This is not poetry masquerading as science, nor is it science stripped of beauty. This is the recognition that the deepest scientific understanding and the most profound poetic vision point toward the same truth. They are two languages describing the same reality. The atom speaks in mathematics and in metaphor simultaneously. It is both particle and wave, both matter and energy. both individual and part of an infinite whole. The journey we are about to take together will unfold gradually, layer by layer, revealing new dimensions of understanding with each step. We will not rush. There is no need for speed when exploring infinity. We will move at the pace of breath, at the pace of contemplation, allowing each concept to settle into your mind like sediment in still water, creating clarity through stillness. In the coming moments, we will discover what atoms fundamentally are. We will understand their basic structure, the rules that govern them, and the astonishing complexity hidden within their apparent simplicity. We will explore how they dance together, how they communicate through forces we cannot see, how they build everything from the simplest molecules to the most complex organisms. We will trace their origins back to the birth of the universe itself, but more importantly, we will explore what atoms mean. We will ask questions that science alone cannot answer. We will contemplate our relationship to the material world and to each other through the lens of atomic reality. We will discover that understanding atoms is, in many ways, understanding ourselves, understanding the very ground of being itself. The whisper begins now. In the silence of your listening, in the stillness of this moment, the atoms within you are resonating with the concepts you are about to receive. They are preparing to reveal their secrets. They are ready to speak. Are you ready to listen? The foundation, understanding what atoms really are. As we move deeper into atomic reality, imagine the fundamental building block of all matter, not as a concept, but as a tangible entity with its own existence, its own rules, its own way of being in the universe. An atom is not a tiny version of the objects we see in the everyday world. It is something far more strange and wonderful, something that behaves according to principles that seem to defy our intuition about how reality should work. At the very heart of an atom lies the nucleus, a dense core containing most of the atom's mass. This nucleus is extraordinarily small. If you were to enlarge an atom to the size of a football stadium, the nucleus would be no larger than a grain of sand at the center of the field. Yet within this minuscule space, tremendous power is concentrated. The nucleus contains protons and neutrons, particles so tightly bound together that separating them releases energy on a scale that can transform entire cities. Surrounding this nucleus in a region of probability and potential rather than fixed position, we find electrons. These are particles with a negative electrical charge, and they exist in what we might call a cloud of possibility around the nucleus. The electrons do not orbit the nucleus like planets around a sun, as we once thought. Instead, they exist in a state of quantum potential. They are both here and not here, both particle and wave, until we observe them, at which point they seem to collapse into a definite location. This is one of the first strange truths about atoms. Reality at the atomic scale operates differently from the reality we experience with our senses. An electron cannot be pinned down to a specific location and a specific velocity simultaneously. This is not a limitation of our measurement tools. This is a fundamental feature of reality itself. The universe at its smallest scales is inherently uncertain, inherently probabilistic. Yet from this uncertainty emerges all the order and structure we observe in the larger world. The relationship between the nucleus and its electrons is governed by electromagnetism, one of the fundamental forces of nature. The positively charged nucleus attracts the negatively charged electrons, holding them in their dance of probability around it. The number of electrons orbiting an atom determines its chemical properties. An atom with one electron is hydrogen, the simplest and most abundant atom in the universe. An atom with 6 electrons is carbon, the element that forms the basis of all known life. An atom with 8 electrons is oxygen, essential to respiration and water. The beauty of atomic structure lies in its variety and consistency simultaneously. There are over 100 different types of atoms, each with a different number of protons and electrons, each with its own distinct personality and way of interacting with the world. Yet they all follow the same fundamental rules. They all operate according to the same principles of electromagnetic attraction and quantum mechanics. From this underlying simplicity emerges the astonishing complexity of the physical world. Consider the atom's proportions. If the nucleus were the size of an apple, the electrons would be orbiting in a region extending miles away. The space between the nucleus and the electrons is not empty, however. It is filled with electromagnetic fields, invisible patterns of force and potential that guide and constrain the electron's movements. These fields are just as real as the particles themselves, though we cannot touch them or see them directly. They are part of the atomic architecture, as essential to the structure as the particles they organize. Each type of atom has its own characteristic size, determined by how far the electron cloud extends from the nucleus. Hydrogen atoms are the smallest. Larger atoms, with more electrons and protons, tend to be larger as well. Though the relationship is not perfectly linear, the size of an atom determines how closely it can approach other atoms, which influences how it bonds with them, which ultimately determines what substances it can form and what properties those substances will have. Within the nucleus itself, there is another layer of complexity. Protons and neutrons are themselves made of even smaller particles called quarks, held together by forces so powerful that no amount of energy we can currently generate could separate them. But for our purposes, we need not venture into that subatomic realm. The atom itself provides sufficient mystery and wonder. It is a complete universe in miniature, containing within it all the principles that govern larger scales of reality. The atom possesses a kind of personality, determined by its electron configuration. Some atoms are extremely stable, resistant to change, content to exist alone, or in specific combinations. These are the noble gases: helium, neon, argon. Their electron shells are completely filled, creating a state of perfect satisfaction, if we may anthropomorphize for a moment. Other atoms are restless, eager to interact, quick to gain or lose electrons or to share them with other atoms. These are the reactive elements: sodium, chlorine, fluorine. They drive much of the chemical activity in the universe. The stability of an atom can be understood through the concept of electron shells or energy levels. Electrons occupy specific energy levels around the nucleus, and each level can hold only a certain number of electrons. The innermost shell can hold 2 electrons, the next shell can hold 8, the next can hold 18, and so on. Atoms tend toward stability by filling their outer shells. When an outer shell is not full, the atom experiences what we might call a kind of yearning to complete it. This yearning manifests as chemical reactivity. When atoms come together, they interact through their outer electrons. These interactions are the foundation of chemistry, the foundation of all structure and transformation in the material world. The outer electrons are the atom's way of communicating with one another, of recognizing kindred spirits, of engaging in the intricate dance that creates molecules and compounds. The inner electrons are more stable, less involved in interactions, more content to remain as they are. The history of atomic theory shows us how human understanding has evolved. Ancient Greeks imagined atoms as indivisible units. In the 19th century, scientists discovered that atoms themselves have internal structure. In the 20th century, quantum mechanics revealed that atomic structure operates according to principles more mysterious and counterintuitive than anyone had imagined. And yet, with each new revelation, the fundamental reality of atoms has remained consistent. They are the building blocks of matter. They are ancient. They are everywhere. They are us. What is truly remarkable about atoms is not just their structure, but their behavior. Atoms follow patterns. They prefer certain arrangements. They respond to energy in predictable ways. They remember, in a sense, what other atoms they have bonded with before. They carry information in their configuration. They are not passive recipients of external forces. They are active participants in the dance of creation and transformation that constitutes physical reality. The dance of electrons. How light and matter communicate. When electrons move between energy levels within an atom, something extraordinary happens. They do not gradually transition from one level to another, as if climbing a staircase. Instead, they jump. They leap from one level to another, in what appears to be instantaneous, discontinuous motion. When they make this leap, energy is either released or absorbed. When an electron falls to a lower energy level, it releases energy in the form of light. This is how atoms speak to the universe. This is how they paint color into existence. The light that emerges from an atom's electrons is not random. It has a specific wavelength, a specific frequency, a specific color that depends on exactly how far the electron jumped. An electron falling from the third energy level to the second level releases a different color of light than an electron falling from the fourth level to the second. Each jump corresponds to a specific frequency, a specific note in the cosmic symphony. This is why atoms of different elements produce different colors when they emit light. This is why neon signs glow in distinct colors. This is why the sun produces white light containing all colors mixed together. The relationship between electrons and light reveals something profound about the nature of matter and energy. Light is not separate from atoms. Light is what atoms produce when they transform. Energy and matter are not fundamentally different things. They are two expressions of the same underlying reality. Einstein's famous equation, E equals m times c squared, tells us that matter is concentrated energy, and energy is diffuse matter. An atom is a way that energy organizes itself into a form that persists, that has boundaries, that can be counted and measured. When light strikes an atom, the reverse process can occur. An electron can absorb the light's energy and jump to a higher energy level. This is how atoms receive messages from the universe. This is how the sun's energy enters the material world. When light from the sun hits a plant leaf, electrons in the chlorophyll molecules absorb that light and jump to higher energy levels. This provides the energy for photosynthesis, for the conversion of sunlight into chemical energy, for the building of plant tissue, for the creation of food that sustains all life on Earth. The interaction between light and matter is not symmetrical. Not all atoms can absorb all frequencies of light. Each atom has its own preferred frequencies, its own resonant wavelengths. This is why objects appear to have colors. When white light hits an object, certain frequencies are absorbed by the atoms in that object, and other frequencies are reflected or transmitted. The frequencies that are reflected reach our eyes, and we perceive them as the object's color. A red apple appears red because its atoms absorb all the colors of light except red. The red light bounces off and reaches our eyes, carrying information about the apple's atomic composition. This principle, that atoms have preferred frequencies of light they can absorb and emit, is the foundation of spectroscopy, one of the most powerful tools in science. By analyzing which frequencies of light an object absorbs or emits, scientists can determine what elements are present in that object. This is how astronomers know the composition of distant stars. This is how forensic scientists identify unknown substances. This is how we discovered the composition of the sun's atmosphere. The atoms are speaking, and we have learned to listen to their light. The electrons' dance with light also reveals the quantum nature of reality. Light does not travel as a continuous wave, as we might naively imagine. Light comes in discrete packets called photons, each carrying a specific amount of energy corresponding to its frequency. A high-frequency photon carries more energy than a low-frequency photon. This is why ultraviolet light can damage our skin, while infrared light merely warms us. This is why X-rays can penetrate tissue while visible light cannot. The energy of light is quantized, divided into indivisible units, just like electrons are quantized into discrete energy levels. The dance between electrons and light is also the foundation of how we see. When light enters your eye, it strikes photoreceptor cells in your retina. These cells contain molecules called rhodopsin, which contain electrons that absorb the light's energy. This energy causes the molecules to change shape, which triggers a cascade of chemical reactions, which sends signals to your brain, which interprets those signals as vision. Every moment you see, you are witnessing the dance of electrons and light. You are perceiving the universe through the quantum mechanical interactions of electrons with photons. Consider the moment when light from a distant star reaches your eye. That light has traveled for years through the vacuum of space, carrying information about the star's composition, temperature, and motion. The light, made of photons, quantum particles of energy, strikes your retina and excites electrons in your photoreceptors. Those electrons release that energy through a cascade of chemical reactions that your brain interprets as a point of light in the night sky. In that instant, you are connected to that distant star. You are receiving a message written in light, translated by electrons, interpreted by your consciousness. You are part of the cosmic conversation. The colors we see are not properties of objects themselves. They are the result of interactions between light and atoms. Without light, Without electrons jumping between energy levels, the universe would be entirely dark. The apparent solidity and color and texture of the world around you are emergent properties arising from the quantum mechanical dance of electrons with photons. This does not make the world any less real. It makes it more wondrous. The reality we perceive is not a simple recording of an external world. It is a creation that arises from the interaction between light, atoms, and consciousness. When you look at a sunset, you are seeing the result of light scattering as it passes through the Earth's atmosphere. The blue light scatters easily because of its short wavelength, so it disappears from the direct path of the sun's light. The red and orange light, with longer wavelengths, passes through more directly. But this scattering is not a simple mechanical process. It occurs because the electrons in atmospheric molecules respond differently to different frequencies of light. The sunset is painted by the preferences of electrons. The sky's color is written in the quantum mechanics of electromagnetic interaction. The invisible architecture, how atoms build our world. When atoms come together, they do not simply stack like building blocks. They undergo a profound transformation. The electrons of one atom are influenced by the nuclei of neighboring atoms. New patterns emerge, new possibilities open. The individual atoms, in a sense, merge their identities to create something larger than themselves, while remaining fundamentally themselves. This process of atoms joining together is the foundation of all structure in the universe. The simplest molecule is hydrogen gas, formed when two hydrogen atoms bond together. Each hydrogen atom has one electron. When they approach each other, the electron clouds begin to overlap. Something remarkable happens. Instead of repelling each other, as two negatively charged clouds should theoretically do, the atoms attract. The electrons are drawn toward both nuclei simultaneously. The two atoms share their electrons in a new arrangement that is more stable than either atom alone. They have formed a chemical bond. This bond is not a physical connection like a rope tying two objects together. It is a pattern of electron distribution, a way that the electrons arrange themselves to minimize energy and maximize stability. The bond is electromagnetic in nature, arising from the attraction between the electrons and the nuclei. Yet it is every bit as real as any physical connection. Bonds hold molecules together. Bonds hold us together. Bonds are the invisible architecture upon which all structure depends. Different types of atoms form different types of bonds, depending on their electron configurations and their nuclear charges. Some atoms, like sodium, are willing to lose electrons entirely, becoming positively charged ions. Other atoms, like chlorine, are eager to gain electrons, becoming negatively charged ions. When sodium and chlorine come together, sodium transfers an electron to chlorine. They form an ionic bond, an electrostatic attraction between oppositely charged ions. This is how salt is formed. This is how many minerals are structured. Other atoms, like carbon, prefer to share electrons. Carbon can form 4 covalent bonds, sharing electrons with 4 other atoms. This ability to form multiple bonds in various configurations allows carbon to create an astounding variety of structures. Carbon atoms can bond with each other in long chains, creating hydrocarbons. They can bond with hydrogen, oxygen, nitrogen, and other elements, creating the vast diversity of organic molecules. Carbon is the basis of all known life because of its versatility as a bonding partner. The geometry of molecular structure matters profoundly. A molecule is not a random collection of atoms. It has a shape determined by the angles at which bonds form. Water, for instance, consists of 2 hydrogen atoms bonded to 1 oxygen atom. But the 2 hydrogen atoms are not arranged in a straight line on opposite sides of the oxygen. Instead, they form a bent shape with an angle of about 104 degrees between them. This seemingly small detail, the angle of the bonds, determines water's remarkable properties. Because of its bent shape, water molecules are asymmetrical. The oxygen nucleus, with its 8 protons, pulls the electrons more strongly than the hydrogen nuclei do. This creates a slight negative charge on the oxygen side of the molecule and slight positive charges on the hydrogen sides. Water is a polar molecule. It has a positive end and a negative end. This polarity is the foundation of water's remarkable properties. It is why water dissolves so many substances. It is why water forms into droplets. It is why water can hold so much heat. It is why life as we know it depends on water. The architecture of molecules extends into larger and larger structures. Proteins are long chains of amino acids bonded together, each amino acid being a complex molecule in itself. The shape of a protein, determined by the angles and arrangements of its atomic bonds, determines its function. A protein might form a channel through a cell membrane, or fold into an enzyme that catalyzes a chemical reaction, or arrange itself into a fiber that provides structural support. The same elements, carbon, hydrogen, nitrogen, oxygen, and a few others, arranged in different patterns, create the vast diversity of proteins that make life possible. DNA, the molecule that carries genetic information, is also constructed from atoms arranged in a specific architecture. The famous double helix shape arises from the way that hydrogen bonds form between complementary bases. The sequence of bases, adenine, thymine, guanine, and cytosine, codes for the sequence of amino acids in proteins. The atoms are literally writing the instructions for life. The invisible architecture of atomic bonds has created a system capable of storing, retrieving, and expressing information. It has created a system that can replicate itself. It has created a system that can evolve. Crystals represent another remarkable form of atomic architecture. In a crystal, atoms arrange themselves in a repeating three-dimensional pattern that extends throughout the entire structure. Diamond is crystalline carbon, with each carbon atom bonded to 4 other carbon atoms in a tetrahedral arrangement. This creates an extraordinarily strong structure. Quartz is crystalline silicon dioxide, with silicon atoms bonded to oxygen atoms in a repeating pattern. Snowflakes are crystalline water, with water molecules arranging themselves in hexagonal patterns determined by the geometry of hydrogen bonding. The fact that atoms arrange themselves into regular patterns is not accidental. It is the result of atoms seeking the lowest energy configuration, the most stable arrangement. When atoms have the opportunity to organize themselves, they naturally form structures that minimize energy. This is why crystals form. This is why molecules have specific shapes. This is why atoms in a solid are arranged in orderly patterns rather than random positions. The atoms are following rules, pursuing stability, creating order from the raw material of atomic existence. When you hold a crystal in your hand, you are holding billions upon billions of atoms arranged in a perfectly regular pattern. The transparency of the crystal arises from the way light passes through the regular atomic structure without being scattered. The hardness of the crystal arises from the strong bonds between atoms. The beauty of the crystal arises from the mathematical perfection of its atomic arrangement. You are holding frozen geometry. You are holding the visible expression of atomic preference for order and stability. The invisible architecture built by atoms extends into living systems. Your body is constructed from atoms arranged in astonishingly complex patterns. Cells contain organelles. Organelles contain molecules. Molecules contain atoms. At each level, the arrangement of components at the lower level determines the properties and functions at the higher level. Your consciousness arises from the electrical and chemical activity of neurons, which are cells built from molecules, built from atoms. You are a structure of extraordinary complexity, built from the simplest possible components, atoms and the bonds between them. The rhythm of bonds. Why atoms choose to connect. In the quiet depths of atomic reality, there exists a fundamental principle that governs all interaction. Atoms do not randomly collide and stick together. They do not form bonds out of chance or accident. Instead, atoms are drawn together by forces, guided by preferences, organized by principles as precise as the laws of music or mathematics. To understand why atoms bond is to understand the deep logic of existence itself. Every atom possesses what we might call an electron appetite, a preference for a certain number of electrons in its outer shell. Atoms with full outer shells are content, stable, resistant to change. These are the noble gases, atoms that rarely form bonds with other atoms because they have already achieved their preferred electron configuration. But most atoms have incomplete outer shells. They are restless, they are unsatisfied. This dissatisfaction drives them to interact with other atoms. When atoms come into proximity, they sense each other's electron clouds. They respond to the electromagnetic fields generated by each other's nuclei and electrons. If bringing their electrons together would result in a more stable configuration for both atoms, they will bond. This is not a conscious choice in any human sense, yet it is a choice nonetheless. The atoms are responding to physical principles, following the path of lowest energy, organizing themselves according to the laws of thermodynamics. Consider what happens when a hydrogen atom meets another hydrogen atom. Each has one electron and hungers for one more to complete its shell. When they approach, their electron clouds begin to overlap. The electrons are attracted to both nuclei. They spend more time in the space between the two nuclei than they would if the atoms were separate. This shared electron arrangement is lower in energy than two separate atoms. The bond forms naturally, spontaneously, because it is more stable than the alternative. The strength of a bond depends on how much energy is released when the atoms join. A strong bond releases a great deal of energy. Breaking that bond requires putting that energy back in. A weak bond releases little energy and can be broken easily. This explains why some substances are very stable and others are easily decomposed. It explains why some reactions release enormous amounts of energy, while others require external energy to proceed. When atoms bond, they do not necessarily bond to just one other atom. Many atoms can form multiple bonds simultaneously. A carbon atom, for instance, has 4 electrons in its outer shell and can accommodate 4 more. So it forms 4 bonds, typically with 4 other atoms. These 4 bonds can be with 4 different atoms, or some atoms might share multiple bonds with the same partner. A carbon atom might form a double bond with 1 oxygen atom and single bonds with 2 hydrogen atoms. The variety of bonding possibilities is vast. The angles at which bonds form are not arbitrary. They are determined by quantum mechanical principles governing how electron clouds arrange themselves to minimize repulsion and maximize attraction. Electrons, being negatively charged, repel each other. When an atom forms multiple bonds, the electron clouds distribute themselves around the nucleus in a way that keeps them as far apart as possible while still being attracted to the nuclei. This creates predictable angles and geometries that determine molecular shape. Some bonds are stronger than others. Covalent bonds, where electrons are shared, are typically quite strong. Ionic bonds, where electrons are transferred from one atom to another and the resulting ions are held together by electrostatic attraction, are also strong. Hydrogen bonds, where a hydrogen atom bonded to an electronegative atom like oxygen or nitrogen is attracted to another electronegative atom, are weaker. Van der Waals forces, the weak attractions between molecules caused by temporary fluctuations in electron distribution, are weaker still. Yet even weak bonds are important. Hydrogen bonds hold water molecules together and allow water to exist as a liquid rather than a gas at room temperature. Hydrogen bonds between the bases in DNA allow the double helix to form while still allowing the 2 strands to separate when needed for replication. Van der Waals forces allow gases to liquefy at low temperatures. The weakness of these bonds is actually an advantage in biological systems, where bonds need to form and break repeatedly as molecules interact and rearrange. The process of bond formation is not instantaneous, though it may seem so on a macroscopic timescale. When 2 atoms approach each other, their electron clouds begin to interact. The electrons are attracted to the foreign nucleus, while simultaneously repelled by the foreign electron cloud. There is a distance at which the attractive and repulsive forces balance. This is the equilibrium distance, the preferred separation at which the bond is strongest. If the atoms get closer, repulsion increases. If they move farther apart, attraction weakens. The energy landscape around bonding atoms can be visualized as a valley. The valley represents low energy, stable configurations. The walls of the valley represent high energy, unstable configurations. Atoms naturally roll down into the valley, settling into the lowest energy configuration available to them. This is not a conscious process. It is the inevitable result of physical laws. Atoms are not choosing to bond any more than a ball is choosing to roll downhill. They are simply following the path dictated by the laws of physics. When bonds break, energy is required. This is why chemical reactions often require heat or light or other external energy sources. The atoms are being forced out of the valley, forced to separate despite the attractive forces holding them together. Once the bond is broken, the energy is released as heat or light, or is stored in the form of chemical potential energy in the newly separated atoms. This is how explosives work. This is how fire releases energy. This is how cells extract energy from food. The formation and breaking of bonds is happening constantly throughout the universe. In stars, atoms are fused together, forming heavier elements and releasing enormous amounts of energy. In your cells, bonds in food molecules are broken, releasing energy that powers your body's activities. In the Earth's interior, chemical reactions driven by heat transform minerals into new forms. The dance of bonding and unbonding is the fundamental activity of matter. It is the process through which change and transformation occur, the energy symphony, where movement becomes heat and light. Atoms are not static structures frozen in place. They vibrate, they move, they oscillate. Every atom in every molecule at every moment is in motion, driven by the energy it possesses. This motion is not random chaos. It follows patterns. It has rhythm. It is the vibration of atoms that creates what we experience as heat and cold, that generates the light we see, that powers the chemical reactions that sustain life. The energy possessed by atoms exists in many forms. Kinetic energy is the energy of motion. An atom moving rapidly has more kinetic energy than an atom moving slowly. Potential energy is the energy stored in the bonds between atoms or in the positions of electrons within atoms. A molecule with strong bonds has more potential energy stored in those bonds than a molecule with weak bonds. Thermal energy is the total kinetic energy of all the atoms in a substance. When we speak of temperature, we are actually describing the average kinetic energy of atoms. A hot substance contains atoms moving rapidly. A cold substance contains atoms moving slowly. This is why heat flows from hot objects to cold objects. The rapidly moving atoms in the hot object collide with the more slowly moving atoms in the cold object, transferring energy through collision. Eventually, the atoms in both objects reach similar average kinetic energies, and thermal equilibrium is reached. The motion of atoms is constrained by their bonds. Atoms in a solid cannot move freely. They are locked in place by strong bonds to their neighbors. They can only vibrate around their equilibrium positions, like bells ringing or springs oscillating, but they do vibrate. They vibrate constantly, even at extremely low temperatures. Even at absolute zero, if we could reach it, atoms would still vibrate slightly due to quantum mechanical principles. This is called zero-point energy, the irreducible minimum energy that atoms possess. In a liquid, atoms have more freedom. They can move around, flowing past each other, but they are still held loosely to their neighbors by attractive forces. The atoms vibrate more vigorously than in a solid, and they also translate, moving from place to place. The viscosity of a liquid, how easily it flows, depends on how much the atoms collide with each other as they move. A thick, viscous liquid contains atoms that collide frequently. A thin liquid contains atoms that move more freely. In a gas, atoms have even more freedom. They move rapidly through space, colliding with each other and with the walls of their container. The pressure of a gas is caused by the bombardment of atoms against the container walls. The more atoms, the more collisions, the higher the pressure. The faster the atoms are moving, that is, the higher the temperature, the more forcefully they collide and the higher the pressure. This relationship between pressure, volume, temperature, and the number of atoms is expressed in what we call the ideal gas law. When atoms collide, they can transfer energy. A fast-moving atom colliding with a slow-moving atom will slow down somewhat, and the slow-moving atom will speed up. Through countless collisions, energy is distributed throughout a substance, eventually reaching an average where all atoms have similar kinetic energies. This is how heat spreads through matter. This is how a cold object warmed by placing it near a hot object gradually reaches the same temperature. But the motion of atoms is not limited to translation and vibration. Atoms can also spin and rotate. Molecules can rotate around their bonds. Electrons can orbit at different velocities. All of these forms of motion represent different ways that energy can be stored in atoms and molecules. The more energy a system has, the more ways that energy can be distributed among these different forms of motion. When energy is added to a substance, for instance, when you heat it, the atoms begin to move faster. If enough energy is added, atoms can break free from their bonds. A solid melts into a liquid. If even more energy is added, atoms can escape entirely into the gas phase. A liquid evaporates into a gas. Each of these phase transitions requires energy because atoms must overcome the attractive forces holding them together. The reverse is also true. When energy is removed from a substance, when you cool it, atoms move more slowly. When enough energy is removed, atoms can no longer overcome attractive forces. A gas condenses into a liquid. A liquid freezes into a solid. The energy released during these phase transitions can be substantial. This is why steam burns so severely. As it condenses into liquid water, it releases a large amount of energy. This is why ice is useful for cooling drinks. As it melts, it absorbs a large amount of energy. Chemical reactions involve atoms breaking free from their current bonds and forming new bonds. This requires energy to break the old bonds and releases energy when new bonds form. If more energy is released than is required, the reaction is exothermic. It releases heat. If more energy is required than is released, the reaction is endothermic. It absorbs heat. The energy released by exothermic reactions manifests as heat, light, sound, or motion. This is how fire burns. This is how explosions occur. This is how your body generates the heat that maintains your body temperature. The sun is a vast engine of atomic transformation. In the sun's core, atoms are crushed together with such force that the nuclei fuse, forming heavier elements. This nuclear fusion releases enormous amounts of energy. This energy is released as heat and light that radiates outward, warming the planets and sustaining life on Earth. The light reaching your eyes right now, if you are reading during the day, is the result of nuclear fusion in the sun. The food growing in fields is powered by this light. The fossil fuels we burn were formed from ancient organisms powered by this same light. The sun's atomic fusion is the ultimate source of energy for almost all life on Earth. The memory of matter, how atoms remember their history. This is a profound truth that science is only beginning to fully appreciate. Atoms carry information. They are not blank slates. They are not interchangeable units. Atoms possess a kind of memory, encoded in their structure, in their configuration, in the patterns of bonds they have formed. This memory shapes how atoms will interact in the future. This memory is the basis of how matter changes, how it transforms, how it learns. Consider an atom that has been bonded to other atoms for millions of years. The bonds have shaped its electron distribution. The neighboring atoms have influenced its properties. When that atom is released from its bonds, it does not return to some neutral, pristine state. It retains the influence of its previous interactions. If it forms new bonds, those new bonds are influenced by its history. The atom is not the same as it would have been if it had never bonded before. This principle extends to molecules and crystals. A crystal that forms slowly, allowing atoms to arrange themselves carefully and deliberately, will have a different structure than a crystal that forms quickly. The atoms in the slowly formed crystal have had time to find their optimal positions, creating a more perfect, more regular structure. The atoms in the quickly formed crystal are frozen in positions that are less than optimal, creating defects and irregularities. These defects affect the crystal's properties. The crystal's history is written in its structure. The concept of chemical equilibrium reflects this memory. When a chemical reaction is proceeding, forward and reverse reactions are occurring simultaneously. Bonds are being formed and broken. As the reaction proceeds, the concentration of reactants decreases and the concentration of products increases. Eventually, a point is reached where the forward and reverse reactions are occurring at the same rate. The system reaches equilibrium, but this equilibrium is not the same as stasis. Change is still occurring, but the overall concentrations remain constant. When a system at equilibrium is disturbed, for instance, if more reactant is added, the system responds by shifting the equilibrium. The forward reaction proceeds faster than the reverse reaction, consuming the added reactant and producing more product until a new equilibrium is reached. The system remembers its previous equilibrium and adjusts to restore balance. This is called Le Chatelier's principle, and it reflects the fact that atoms and molecules are not passive victims of circumstances. They actively respond to changes in their environment. The memory of matter is particularly evident in the behavior of water. Water can exist in multiple phases: solid ice, liquid water, and gaseous steam. Each phase has different properties because the atoms are arranged differently and moving at different speeds. But the memory of water's previous state influences its behavior. Water that has been heated and then cooled retains some memory of having been heated. It may crystallize differently or exhibit slightly different properties than water that was never heated. This is one reason why laboratory water must be carefully treated and stored. Its history affects its properties. The memory of atoms is also evident in the process of annealing. When a metal is heated and then slowly cooled, its properties change. The heat allows atoms to move around, breaking out of imperfect configurations and finding more optimal arrangements. As the metal cools, the atoms freeze in place in these improved configurations. The metal becomes stronger, less brittle, more workable. The atoms have had the opportunity to remember the optimal arrangements and to settle into those arrangements. The metal's history of being heated and cooled is encoded in its improved properties. This principle has profound implications for understanding how life works. Your cells contain molecules that have been shaped by billions of years of evolution. The proteins in your body are folded into specific three-dimensional shapes that are the result of countless generations of natural selection. These shapes are encoded in the sequence of amino acids, which is encoded in the DNA, which is encoded in the sequence of bases. The atoms in your body are arranged in patterns that reflect the history of life on Earth. Your own body also remembers. When you learn something new, the connections between your neurons are strengthened through the formation of new synapses and the modification of existing ones. These modifications involve the growth of new proteins and the reorganization of molecular structures. Your memory is written in the structure of atoms and molecules in your brain. When you recall a memory, you are reactivating patterns of atomic activity that were established in the past. Your history is literally encoded in the structure of matter in your brain. Habit formation works through the same principle. When you repeat a behavior, the neural pathways associated with that behavior are strengthened. Atoms and molecules are reorganized in patterns that make the behavior easier to repeat in the future. The more you repeat a behavior, the more deeply it is encoded in the atomic structure of your brain. Eventually, the behavior becomes automatic, requiring less conscious effort. The atoms have learned. They have adjusted their patterns to reflect the history of your actions. This explains why change is difficult. Your body, your brain, your habits are all encoded in the structure of atoms and molecules. Changing your behavior requires reorganizing these structures. It requires atoms to move into new configurations, new patterns. This is possible. Atoms are constantly moving, constantly rearranging, but it requires energy and repetition. The more firmly a pattern is established, the more energy is required to change it. The atoms remember the old pattern and resist the new one. But atoms can change. They do change constantly, every moment. Atoms are breaking free from old bonds and forming new ones. Every moment, your body is breaking down old molecules and building new ones. Your cells are dying and being replaced. Your atoms are being recycled. The matter that makes up your body is not the same matter that made up your body a year ago. The atoms have changed, yet you remain yourself because the patterns, the information, the memory encoded in the arrangement of atoms has been preserved and copied. The quantum breath, the uncertainty that holds reality together. At the heart of atomic reality lies something that defies our intuition about how the world should work. It is called the uncertainty principle, and it is not a limitation of our measuring instruments or a temporary gap in our knowledge. It is a fundamental feature of reality itself. At the quantum level, reality is inherently uncertain. The universe does not have definite properties until they are observed. Before observation, particles exist in a state of superposition. They are, in a sense, all possibilities at once. This uncertainty is not chaos. It is not randomness in the ordinary sense. It is something more subtle and profound. An electron does not have a definite position in space until it is measured. Before measurement, it exists as a wave function, a mathematical description of probability. When we measure the electron's position, the wave function collapses, and the electron appears at a specific location. But if we measure the electron's momentum instead, the wave function collapses into a state where momentum is definite, but position is uncertain. This is the essence of the uncertainty principle. Position and momentum cannot both be known with arbitrary precision simultaneously. The more precisely we know an electron's position, the less precisely we can know its momentum. The more precisely we know its momentum, the less precisely we can know its position. This is not because our measurements are imperfect. It is because reality itself does not assign definite values to both properties simultaneously. The universe is constructed in such a way that perfect knowledge of all properties is impossible. This might seem like a terrible flaw in reality, a cosmic joke that denies us complete understanding, but it is actually what allows atoms to exist. If electrons had definite positions and velocities, they would spiral into the nucleus, collapsing in a fraction of a second. The uncertainty principle prevents this collapse. An electron cannot have both a definite position inside the nucleus and a definite velocity pointing inward. The uncertainty ensures that electrons maintain a cloud-like distribution around the nucleus, never quite falling in, never quite escaping. The uncertainty principle extends beyond position and momentum. Energy and time are also subject to uncertainty. The shorter the time interval we consider, the less certain the energy can be. This means that in very short time intervals, energy can fluctuate wildly. Particles can appear and disappear. A vacuum is not truly empty. It is seething with virtual particles constantly appearing and disappearing, borrowing energy from the uncertainty principle and returning it almost instantaneously. This quantum foam, as it is sometimes called, is not merely theoretical. It has observable consequences. It affects how atoms behave. It influences the behavior of particles at extremely high energies. It may have played a role in the creation of the universe itself. The universe did not emerge from absolute nothingness. It emerged from quantum uncertainty, from the possibility of fluctuations in the quantum field that underlies all of reality. The uncertainty principle also has implications for how we understand causality. In classical physics, the future is completely determined by the present state of the system. If we know all the properties of a system right now, we can calculate its state at any future time. But in quantum mechanics, this is impossible. Even if we know as much as the uncertainty principle allows us to know about a system right now, we cannot predict with certainty what will happen next. There is an irreducible randomness in nature. Yet this randomness is not lawless. It is constrained by probabilities. The wave function does not tell us exactly where an electron will be found when we measure it, but it tells us the probability of finding it at different locations. Some locations are more probable than others. The electron is more likely to be found in regions where the wave function is large, and less likely to be found in regions where it is small. The randomness follows rules. It is random, but not arbitrary. This probabilistic nature of quantum mechanics troubled many physicists. Albert Einstein, in particular, was deeply uncomfortable with it. He believed that quantum mechanics was incomplete, that there must be hidden variables determining the outcome of quantum events that we simply did not know about. He said, "God does not play dice with the universe, but experiments have since shown that Einstein was wrong. The universe does play dice. Randomness is fundamental. There are no hidden variables that would make the universe deterministic. The quantum breath, the constant fluctuation and uncertainty at the heart of reality, is what allows transformation and change. If everything were determined, if every event was completely predictable from initial conditions, the universe would be static and unchanging. But because of quantum uncertainty, new possibilities are constantly emerging. Atoms can make transitions that classical physics would forbid. Particles can tunnel through barriers. Reactions can occur that should be impossible. The uncertainty is the source of novelty and possibility. This also has implications for free will and consciousness. If the universe were completely deterministic, then our choices would be completely predetermined. There would be no genuine freedom. But if the universe is fundamentally probabilistic, then there is room for genuine randomness in neural processes. This does not prove that we have free will. Randomness is not the same as freedom, but it opens the possibility that consciousness is not simply the mechanical execution of predetermined events. The quantum breath leaves space for something more. The uncertainty principle teaches us something profound about the nature of knowledge and reality. We cannot know everything about a system. We cannot measure all properties with arbitrary precision. This is not a limitation of technology or intelligence. It is a feature of reality. The universe is constructed in such a way that complete knowledge is impossible. There will always be mystery. There will always be aspects of reality that escape our understanding. The universe is fundamentally uncertain, fundamentally mysterious, fundamentally open to possibility. The stellar origin, where every atom in your body was born in the beginning, there was light. In the first fraction of a second after the Big Bang, the universe was too hot for any structure to exist. It was a soup of fundamental particles and energy. As the universe expanded and cooled, these particles began to combine, forming the first atoms. The first atoms were hydrogen and helium, the simplest elements. These atoms were born in the furnace of the Big Bang itself. For millions of years, the universe was dark. These first atoms drifted through space, pulled together by gravity, forming the first stars. The stars were massive, hot, and short-lived. In their cores, temperatures and pressures were so extreme that hydrogen atoms were fused together, forming helium atoms. This nuclear fusion released enormous amounts of energy, causing the stars to shine brilliantly. But it also transformed the atomic composition of the universe. As stars burned through their hydrogen fuel, fusing it into helium, heavier elements were created. Helium atoms were fused together, forming carbon, nitrogen, and oxygen atoms. As stars grew older and hotter, carbon atoms were fused into neon and magnesium atoms. Oxygen atoms were fused into silicon and sulfur atoms. Each generation of fusion created heavier elements. Each element represents a new layer in the cosmic onion of creation. But there is a limit to how heavy an element can be created through fusion. When iron is formed through fusion, it takes energy to fuse it further rather than releasing energy. Iron cannot power a star. When a massive star has burned through all its fuel, creating a core of iron, the star can no longer support itself against its own gravity. The core collapses catastrophically. The star explodes in a supernova. In the violent explosion of a supernova, conditions are so extreme that even heavier elements are created. Iron is fused into nickel, cobalt, and other heavy elements. Nickel decays into iron over time. The energy of the explosion is so tremendous that it blows the star apart, scattering all these elements throughout space. Atoms created in the core of the star are flung across light years of space. They become part of vast clouds of gas and dust, drifting through the galaxy. In these clouds, gravity pulls the atoms together again. New stars form. Around these new stars, planets condense from the disk of material surrounding them. The atoms that were created in the hearts of dying stars billions of years ago become the material of planets. The iron in your blood was created in a supernova billions of years ago. The oxygen you breathe was created in a massive star's core. The calcium in your bones was forged in stellar furnaces. Your body is made of stardust. This is not poetry. It is literal scientific fact. Every heavy element in your body, every atom heavier than helium, was created in a star. You are the universe aware of itself. You are the cosmos experiencing itself through a human perspective. The atoms that make up your body have journeyed from the furnace of a star through the vacuum of space into the solar nebula that formed our sun and planets, into the early Earth, through the emergence of life through billions of years of evolution, and finally into the specific arrangement that constitutes your body right now. The iron in your blood came from a star that died before the sun was born. The oxygen in your lungs came from a star that may have died long before the Earth formed. These atoms have been part of countless beings throughout history. They have been part of dinosaurs and mountains and oceans and forests. They have been recycled countless times, yet they have maintained their identity. An iron atom is an iron atom whether it is in a star or in your blood. An oxygen atom is an oxygen atom, whether it is in the atmosphere of a dead star or in the water in your cells. This continuity across cosmic time is remarkable. The atoms that make up your body are ancient. They have existed since near the beginning of the universe. They have traveled unimaginable distances. They have undergone countless transformations. They have been part of living and non-living systems, yet they persist. They maintain their fundamental nature. An atom is not destroyed or created. It is transformed, rearranged, combined with other atoms, but its essential nature persists. The process of stellar nucleosynthesis, the creation of elements in stars, is how the universe became diverse. The early universe contained only hydrogen and helium. Without the creation of heavier elements in stars, without the scattering of those elements into space through supernovae, without the formation of planets from that enriched material, life as we know it could not exist. Carbon, nitrogen, oxygen, phosphorus, sulfur, all the elements essential for life were created in stars and scattered by supernovae. When you contemplate the atoms in your body, you are contemplating the history of the universe. You are holding within yourself pieces of ancient stars. You are the temporary custodian of atoms that have existed for billions of years. You are the vehicle through which the universe experiences itself. The atoms in your consciousness right now, the atoms that make up your brain and allow you to think and feel and understand, are atoms that were forged in the hearts of stars and have journeyed across the cosmos to this moment. The transformation mystery. How atoms change their identity. An atom's identity is determined by the number of protons in its nucleus. An atom with 1 proton is hydrogen. An atom with 6 protons is carbon. An atom with 8 protons is oxygen. This number cannot change without changing the atom's identity fundamentally. Yet atoms do change their identity. Through radioactive decay, through nuclear fusion, through nuclear fission, atoms can transform from one element into another. This transformation is one of the deepest mysteries of atomic reality. Radioactive decay occurs when an atom's nucleus is unstable. The nucleus contains protons and neutrons held together by the strong nuclear force. But if the ratio of protons to neutrons is wrong, the nucleus becomes unstable. It cannot maintain its current configuration indefinitely. Eventually, the nucleus will spontaneously rearrange itself, releasing energy and particles in the process. The atom transforms into a different element. There are several types of radioactive decay. In alpha decay, the nucleus emits an alpha particle, which is a helium nucleus consisting of 2 protons and 2 neutrons. The atom loses 2 protons and 2 neutrons, so it becomes an atom with 2 fewer protons, a different element with an atomic number 2 less than the original. In beta decay, a neutron transforms into a proton, releasing an electron and an antineutrino in the process. The atom gains a proton, so its atomic number increases by 1, making it a different element. In gamma decay, the nucleus emits a gamma ray, which is a high-energy photon. This does not change the number of protons or neutrons, but it does release energy from the nucleus, bringing it to a lower energy state. A nucleus in an excited state can emit gamma rays to reach a more stable configuration. The atom's identity remains the same, but its energy state changes. The remarkable thing about radioactive decay is that it is random. We cannot predict exactly when a particular atom will decay. We can only predict the probability that it will decay within a certain time period. This is where quantum uncertainty manifests at the nuclear scale. The nucleus is subject to the same quantum mechanical principles that govern electrons. The nucleus exists in a superposition of states, both decayed and not decayed, until the decay actually occurs. Yet, despite the randomness of individual decay events, the collective behavior of large numbers of atoms is predictable. If you have a large sample of radioactive atoms, you can predict how many will decay in a given time period with remarkable accuracy. This is because the law of large numbers applies. With billions or trillions of atoms, the random variations average out, and the overall pattern becomes clear. Half of the atoms will decay within a characteristic time called the half-life. After another half-life, half of the remaining atoms will decay, and so on. Different radioactive elements have different half-lives. Some elements are unstable and decay almost instantaneously. Others persist for millions or billions of years. Carbon-14, which is used for radiocarbon dating, has a half-life of about 5,700 years. Uranium-238 has a half-life of about 4.5 billion years. This is why some radioactive elements are dangerous. They persist in the environment for extremely long times. Other elements decay so quickly that they are dangerous only if you are exposed to fresh samples. The energy released during radioactive decay is substantial. This is the energy that powers nuclear reactors and nuclear weapons. It is also the energy that heats the Earth's interior. The slow decay of radioactive elements deep within the Earth generates heat that drives plate tectonics, volcanic activity, and the circulation of the Earth's mantle. The Earth is still warm from its formation, partly because of the gravitational energy released when it formed, but also because of the steady decay of radioactive elements within it. Radioactive decay is one way atoms change their identity, but there are others. In nuclear fusion, two nuclei combine to form a heavier nucleus. This is how elements heavier than hydrogen are created in stars. Two hydrogen nuclei, protons, can fuse to form a deuteron, a nucleus containing a proton and a neutron. Two deuterons can fuse to form a helium nucleus. This process releases enormous amounts of energy, which powers stars. In nuclear fission, a heavy nucleus splits apart into lighter nuclei. This is what happens in a nuclear reactor or a nuclear weapon. A uranium nucleus is struck by a neutron and splits into two lighter nuclei, releasing energy and additional neutrons that can strike other uranium nuclei, causing them to split as well. This creates a chain reaction, releasing tremendous amounts of energy in a very short time. All of these processes, alpha decay, beta decay, gamma decay, fusion, and fission, involve the transformation of one element into another. They involve the rearrangement of the fundamental building blocks of matter at the nuclear level. They demonstrate that atoms are not immutable. They can change, they can transform, they can become something entirely different while still being made of the same fundamental particles, protons, neutrons, and electrons. This has profound implications for understanding matter. The elements are not eternal and unchanging. They are products of cosmic processes. They are created in stars, transformed through radioactive decay, recycled through nuclear reactions. The periodic table of elements is not a catalogue of eternal substances. It is a snapshot of atomic configurations that exist at this moment in cosmic history. Over billions of years, the distribution of elements in the universe has changed and will continue to change. The silence between empty space and the forces that fill it. Between atoms lies space, vast, seemingly empty space. If an atom were the size of a football stadium, the nucleus would be a grain of sand at the center, and the electrons would be orbiting in a cloud perhaps a mile away. The space between is almost entirely empty. Yet this empty space is not truly empty. It is filled with fields, electromagnetic fields, gravitational fields, and quantum fields that underlie all of reality. A field is not a thing in the ordinary sense. It is not made of matter. It is not made of energy. It is a fundamental aspect of reality, a pattern of influence that extends throughout space. At every point in space, there is a value for each field. The electromagnetic field has a value at every point. The gravitational field has a value at every point. These fields determine how particles interact with each other. The electromagnetic field is what holds atoms together. The negatively charged electrons are attracted to the positively charged nucleus through the electromagnetic field. When two atoms approach each other, their electromagnetic fields interact. If the atoms are compatible, they bond. If they are not compatible, they repel each other. The electromagnetic field is the medium through which atoms communicate with each other. The gravitational field is what holds the universe together on large scales. Every mass creates a gravitational field that extends throughout space, pulling on other masses. The Earth's gravitational field holds you to the ground and keeps the Moon in orbit. The Sun's gravitational field holds the planets in their orbits. The gravitational fields of billions of stars hold galaxies together. Gravity is the weakest of the fundamental forces, but it acts on all matter and has infinite range. Between the nucleus and the electrons, there is the strong nuclear force. This force is what holds protons and neutrons together in the nucleus. It is the strongest of the fundamental forces, but it has extremely short range. It only acts over distances of about a femtometer, the width of a nucleus. Without the strong nuclear force, nuclei would fly apart from the electromagnetic repulsion between protons. The strong nuclear force overcomes this repulsion and holds the nucleus together. There is also the weak nuclear force, responsible for radioactive decay. It is stronger than gravity, but much weaker than the electromagnetic force. The weak force is responsible for the transformation of quarks inside neutrons and protons, allowing neutrons to decay into protons and vice versa. It is the weak force that drives the sun's fusion reactions, converting protons into neutrons and releasing the energy that powers stars. These four fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, govern all interactions in the universe. They are mediated by fields that permeate space. Particles interact by exchanging other particles called force carriers. Photons carry the electromagnetic force. Gluons carry the strong nuclear force. W and Z bosons carry the weak force. Gravitons carry gravity, though gravitons have not yet been directly observed. The quantum fields underlying these forces are strange and wonderful. According to quantum field theory, particles are not fundamental. Fields are fundamental. Particles are excitations of fields, ripples in the quantum fields that underlie reality. An electron is an excitation of the electron field. A photon is an excitation of the electromagnetic field. A quark is an excitation of the quark field. Particles appear and disappear as fields oscillate. This perspective transforms our understanding of what atoms are. An atom is not a collection of particles in empty space. It is a pattern of excitations in quantum fields. The nucleus is an arrangement of quark fields and gluon fields. The electrons are excitations of the electron field. The electromagnetic interaction between nucleus and electrons is mediated by the electromagnetic field. The atom is a structure in the quantum fields, a stable pattern that persists through time. The vacuum, empty space, is not truly empty according to this perspective. It is seething with activity. Virtual particles constantly appear and disappear. The quantum fields are oscillating at their ground state, their minimum energy level. This vacuum energy has observable effects. It influences the behavior of atoms and particles. It may be related to the dark energy that is causing the universe to accelerate in its expansion. The Casimir effect demonstrates that vacuum energy is real and measurable. When two metal plates are placed very close together, the vacuum energy between them is different from the vacuum energy outside. This creates a measurable force pushing the plates together. The empty space between the plates has a measurable effect on the physical world. The vacuum is not passive, it is active. It has properties, it exerts forces. The fields that permeate space are the glue that holds the universe together. They are the medium through which atoms communicate. They are the reason that atoms can influence each other from a distance without any physical contact. They are the reason that the universe is unified, that the same principles apply everywhere, that atoms on Earth follow the same rules as atoms in distant galaxies. When you sit in stillness and contemplate empty space, you are contemplating something that is far from empty. You are contemplating a realm seething with activity, filled with fields and forces, where virtual particles are constantly appearing and disappearing. The silence between atoms is not silence at all. It is the hum of the quantum vacuum, the whisper of fields permeating all of space, the invisible architecture that holds reality together. The consciousness mirror, how matter observes itself. There is a strange paradox at the heart of quantum mechanics. The act of observation changes what is being observed. Before we measure an electron's position, it exists in a superposition of states. It is in multiple places at once, described by a wave function. The moment we measure its position, the wave function collapses, and the electron appears at a specific location. The act of measurement has changed the system. This is not because our measurement apparatus is crude or imperfect. It is because observation requires interaction. To measure an electron's position, we must shine light on it, or use some other method to detect it. This interaction necessarily disturbs the electron. We cannot observe without disturbing. We cannot measure without affecting what we measure. This observation problem has profound implications. It suggests that consciousness and reality are not as separate as we ordinarily assume. The observer and the observed are not independent. They are entangled. The act of observation is not passive, it is active. The observer participates in creating the reality that is observed. Different interpretations of quantum mechanics address this problem in different ways. The Copenhagen interpretation says that the wave function is merely a tool for predicting measurement outcomes. Until a measurement is made, we cannot say anything definite about the system. The wave function collapse is real and occurs when observation happens. The observer plays a fundamental role in creating reality. The many worlds interpretation suggests that the wave function never collapses. Instead, every possible outcome of a measurement actually occurs, each in a different branch of reality. When you measure an electron's position, the universe splits into multiple branches. One where the electron is found at location A, another where it is found at location B, and so on. All possible outcomes occur. You experience just one of these branches. The pilot wave theory suggests that particles are guided by hidden fields that determine their behavior. The wave function is not merely a probability distribution. It is a real wave guiding the particle. In this interpretation, reality is deterministic. The particle's path is completely determined by the pilot wave. But our knowledge of the initial conditions is incomplete, so we can only predict probabilities. Despite the different interpretations, all agree on one thing. There is something special about observation and measurement in quantum mechanics. The observer is not separate from the observed. The act of observation participates in creating what is observed. This is radically different from the classical view where reality exists independently of observers, unaffected by whether anyone is looking at it. This raises a profound question. Is consciousness fundamental to the universe? Does the universe require observers to exist? Some physicists and philosophers have suggested that consciousness plays a special role in quantum mechanics. The physicist John Wheeler proposed that the universe is participatory, that observers and observed co-create reality through the act of observation. The universe began with the Big Bang, billions of years before any observers existed. How could consciousness be fundamental if there were no observers in the early universe? Some speculate that the universe is self-observing. The universe observes itself through the emergence of conscious beings. We are the mechanism by which the universe becomes aware of itself. This is not mere speculation. It follows logically from quantum mechanics. In quantum mechanics, reality is not determined until it is measured. The early universe existed in a superposition of states, but now, billions of years later, observers exist in the universe. These observers measure the universe. The act of observation collapses the superposition. The universe becomes real through being observed by conscious beings within it. This suggests a strange loop. The universe creates the conditions for conscious observers to emerge. These observers measure the universe. The act of measurement creates reality. The universe exists because it is observed. The observers exist because the universe exists. Neither can be said to be primary. They are mutually dependent. They co-create each other. This is not mysticism, though it sounds like it. It follows from the mathematics of quantum mechanics. It is a logical consequence of the theory. The universe is not a machine running according to predetermined laws. It is a participatory reality where observers and observed are entangled. Consciousness is not an accident or a byproduct. It is fundamental to how reality works. Matter observes itself through consciousness. The atoms in your brain are the mechanism through which the universe observes itself. Your consciousness is not separate from matter. It is matter becoming aware of itself. You are the universe experiencing itself from a particular perspective. When you observe an atom, you are not observing something separate from yourself. You are observing yourself, observing a part of yourself with another part of yourself. This transforms our understanding of what we are. We are not separate observers standing outside of nature looking in. We are part of nature. We are nature observing itself. The atoms in our bodies are ancient. The consciousness arising from these atoms is ancient. The universe is ancient. And it is all one thing. The cosmos becoming aware of itself through countless perspectives, countless observers, countless moments of observation. The ancient conversation. Atoms speaking across billions of years. Billions of years ago, when the Earth was young and barren, atoms were already beginning their conversation. In the oceans and the atmosphere, in the rocks and the soil, atoms were bonding and breaking apart, creating and destroying molecules, engaging in the chemical reactions that would eventually lead to life. The atoms that formed the first living cells were the same atoms that exist today. The carbon in the first organic molecules is the same carbon that is in your cells right now. The nitrogen in the first proteins is the same nitrogen that is in your body. The atoms have persisted. They have been recycled countless times. They have been part of countless organisms. Yet they have maintained their identity. When life emerged, atoms began to organize themselves in new ways. They formed molecules capable of replicating themselves. They formed cells capable of metabolism. They began to harness energy from their environment and use it to build more complex structures. The atoms were learning. They were discovering new ways to arrange themselves. They were developing new capabilities. Over millions of years, life diversified. Atoms arranged themselves into plants and animals of countless varieties. Each species represented a new solution to the problem of survival and reproduction. Each species was a new conversation between atoms, a new way that atoms could organize themselves and interact with their environment. The atoms in your body have been part of this evolutionary conversation. The genes in your cells carry information that has been passed down through billions of years of evolution. The atoms in your DNA contain the memory of your evolutionary ancestors. When you look at your hands, you are looking at structures that are descended from the fins of ancient fish. The atoms in your hands are the same atoms that were in those ancient fins. They have been rearranged and modified, but the basic material is the same. The atoms in your brain are particularly remarkable. The human brain is one of the most complex structures in the known universe. It contains billions of neurons, each with thousands of connections to other neurons. These connections allow information to flow through the brain. These connections create thoughts, memories, emotions, consciousness. The atoms have organized themselves into a system capable of reflecting on itself, of questioning its own nature, of contemplating the universe. When you think a thought, you're engaging atoms in a conversation that has been billions of years in the making. The electrical signals flowing through your neurons are atoms moving and interacting. The neurotransmitters released from one neuron to another are molecules made of atoms. The atoms are dancing, communicating, creating the experience of consciousness. This ancient conversation has not ended. It continues right now. Every moment, atoms in your body are breaking old bonds and forming new ones. Every moment, your cells are dying and being replaced. Every moment, atoms that were part of other organisms are entering your body as food and becoming part of you. Atoms that were part of your body are leaving and becoming part of other organisms. The atoms are in constant motion, constantly changing partners, constantly engaging in new conversations. The conversation between atoms extends beyond individual organisms. Plants and animals interact. Predators eat prey. Decomposers break down dead matter. Atoms flow from organism to organism through the food web. The nitrogen in the soil is taken up by plants, incorporated into their proteins, eaten by animals, incorporated into animal tissues, returned to the soil through decomposition. The atoms cycle through the biosphere, constantly changing form, but never disappearing. The atmosphere is also part of this conversation. Carbon dioxide in the atmosphere is taken up by plants through photosynthesis. The carbon is incorporated into plant tissues. Animals eat the plants and incorporate the carbon into their own tissues. When organisms die and decompose, the carbon is released back into the atmosphere as carbon dioxide. The atoms cycle through the biosphere and the atmosphere. The atoms are speaking across the boundary between life and non-life. This is not a one-way conversation. Atoms are not passive players being moved around by external forces. Atoms have preferences. They tend towards certain arrangements. They respond to their environment. They adapt. Over billions of years, evolution has shaped the conversation. Natural selection has favored atoms arranging themselves in ways that are successful at surviving and reproducing. The atoms have learned. They have developed strategies for survival. The atoms in your immune system are engaged in a constant conversation with atoms in pathogens. Your immune cells recognize foreign atoms, and they mount a response. This is an arms race that has been going on for billions of years. Pathogens evolve new ways to hide from the immune system. The immune system evolves new ways to detect and destroy pathogens. The atoms are conversing through evolution. The atoms in your brain are engaged in a conversation with the atoms in your environment. Your senses are constantly picking up information about the world. Light atoms in the form of photons are striking your retina. Sound waves are causing atoms in your ear to vibrate. Molecules from your environment are entering your nose and binding to receptors in your olfactory system. The atoms in your brain are integrating this information, creating a model of the world. This conversation is so ancient and so intricate that it has produced consciousness. Atoms have organized themselves in such a way that they are capable of reflecting on themselves. You are the result of billions of years of atoms learning to organize themselves. You are the universe's way of becoming aware of itself. The atoms are not separate from consciousness. They are the foundation of consciousness. They are the mechanism through which consciousness arises. The resonance within, how your body listens to the atomic whisper. Your body is not a static structure. It is a dynamic system in constant flux. Every moment atoms are vibrating. Every moment molecules are moving. Every moment energy is flowing through your body. Your body is listening to the atomic whisper. It is responding to the vibrations of atoms at every scale. The atoms in your cells are vibrating at specific frequencies. These vibrations are not random. They are organized patterns that reflect the structure of the molecules and the energy available to the system. The vibrations of atoms in proteins determine how those proteins fold. The vibrations of atoms in DNA determine how that DNA interacts with other molecules. The vibrations of atoms in your cells create the rhythm of life. Your heart is beating at a specific rhythm. This rhythm is controlled by electrical signals traveling through the heart muscle. These electrical signals arise from the movement of ions, atoms with excess or deficit electrons, across the membranes of heart cells. Sodium ions, potassium ions, calcium ions are flowing in and out of cells in a coordinated pattern that creates the heartbeat. The atoms are dancing in rhythm. Your heart is listening to this atomic dance. Your brain is oscillating at specific frequencies. These oscillations, called brain waves, arise from the synchronized activity of billions of neurons. Neurons are firing in patterns that create waves of electrical activity that spread through the brain. These brain waves can be measured with an electroencephalogram. Different frequencies of brain waves are associated with different mental states. Delta waves occur during deep sleep. Theta waves occur during light sleep and meditation. Alpha waves occur during relaxation. Beta waves occur during active thinking. Gamma waves occur during intense concentration and problem solving. These brainwave frequencies are not arbitrary. They reflect the fundamental resonance frequencies of neural circuits. Different neural circuits have different natural frequencies. When neurons fire in synchrony, they create oscillations at frequencies that match their natural resonance. The brain is a complex oscillator, vibrating at multiple frequencies simultaneously. Your consciousness arises from the interference patterns of these oscillations. Your body is also responsive to external vibrations. Sound waves are vibrations of air molecules. When sound enters your ear, it causes the eardrum to vibrate. These vibrations are transmitted through tiny bones in the middle ear to the inner ear, where they cause fluid to move. The movement of fluid causes hair cells to bend, triggering electrical signals that travel to the brain. Sound is atoms vibrating, and your body is resonating with these vibrations. Music is particularly powerful at inducing resonance in your body. Different frequencies of sound can entrain brainwaves, can cause your brainwaves to synchronize with the frequency of the sound. Low-frequency music can induce alpha and theta waves, promoting relaxation and meditation. The atoms in your brain are being entrained by the vibrations of atoms in the music. Your consciousness is being shaped by the resonance. Light is also a vibration. Light is electromagnetic waves oscillating at specific frequencies. When light enters your eye, it is absorbed by photoreceptor cells, causing electrons to be excited to higher energy levels. This triggers a cascade of electrical signals that travel to the brain. Your visual perception arises from the resonance between the frequency of light and the structure of your visual system. You are seeing the world as it resonates with your perceptual apparatus. Your sense of smell is also based on resonance. Molecules from your environment bind to receptors in your nose. Each receptor is tuned to recognize molecules with specific shapes and properties. The shape of a molecule determines how it resonates with the receptor. When a good match occurs, the molecule binds to the receptor, triggering electrical signals that travel to the brain. Your sense of smell is the brain interpreting the resonance between molecules and olfactory receptors. Your body maintains a precise internal environment through a process called homeostasis. This requires constant monitoring and adjustment of numerous parameters: temperature, pH, osmotic balance, hormone levels, and countless others. Your body is constantly listening to these parameters and making adjustments to keep them within a narrow range. The atoms in your body are communicating with each other, reporting on the current state and adjusting behavior accordingly. Temperature regulation is a particularly important example. Your body maintains a constant temperature of about 37 degrees Celsius. This is achieved through a balance between heat production and heat loss. When your body temperature drops, your muscles contract in shivering, generating heat. When your body temperature rises, you sweat, and the evaporation of sweat cools your body. The atoms in your body are responding to temperature changes and adjusting their behavior to maintain homeostasis. Your body also responds to stress through the release of hormones like cortisol and adrenaline. These hormones cause atoms throughout your body to adjust their behavior. Your heart rate increases, your breathing accelerates, your muscles tense, your digestion slows. Your immune system is suppressed. The atoms are preparing your body for fight or flight. This is the atomic whisper translated into physical and psychological changes. Your body is also capable of healing itself. When you are injured, specialized cells are activated to repair the damage. Atoms are mobilized to build new tissue. The inflammatory response recruits immune cells to the injured area. Growth factors are released to stimulate cell division and tissue repair. Over days and weeks, the atoms organize themselves into new tissue that replaces the damaged area. Your body is listening to the signals of injury and responding with the wisdom of billions of years of evolution. The infinite recursion. Atoms within atoms within atoms. We have been speaking of atoms as if they are fundamental, indivisible units, but atoms are not truly fundamental. They are made of smaller particles. Atoms are built from nuclei and electrons. Nuclei are built from protons and neutrons. Protons and neutrons are built from quarks. Quarks are held together by gluons, which are themselves excitations of quantum fields. The recursion continues inward, layer after layer, smaller and smaller, deeper and deeper. Each level of this recursion reveals new wonders. At the level of atoms, we see chemistry, the bonding of atoms into molecules, the formation of structures. At the level of nuclei, we see nuclear physics, the binding of protons and neutrons, the release of energy through fusion and fission. At the level of quarks, we see the strong force, the color charge, the confinement of quarks within hadrons. At the level of quantum fields, we see the fundamental nature of reality itself. But the recursion does not stop at quantum fields. Quantum fields are not the final level of reality. They are excitations of something more fundamental. Some physicists speculate about a deeper level of reality, perhaps strings vibrating in multiple dimensions, perhaps something even more fundamental that we have not yet conceived of. The recursion may be infinite. Each level may contain smaller levels within it, all the way down. Simultaneously, the recursion goes upward as well. Atoms combine to form molecules. Molecules combine to form organelles. Organelles combine to form cells. Cells combine to form tissues. Tissues combine to form organs. Organs combine to form organisms. Organisms combine to form ecosystems. Ecosystems combine to form the biosphere. The biosphere is one level in the structure of the Earth. The Earth is one level in the structure of the solar system. The solar system is one level in the structure of the galaxy. The galaxy is one level in the structure of the universe. This is the principle of scale-free organization. The same patterns appear at every scale. A cell nucleus resembles a miniature solar system. A galaxy resembles a miniature atom. The structure of the universe resembles the structure of the atom. This is not coincidence. It reflects deep principles about how order emerges from chaos, how structure forms from the interaction of forces, how organization arises at every scale. The fractal nature of reality is profound. A fractal is a pattern that repeats at every scale. Zoom in on a fractal, and you see the same pattern. Zoom out, and you see the same pattern again. The universe may be a fractal. The same patterns may repeat at every scale, from the quantum foam to the observable universe. Consider the hydrogen atom. At the center is a nucleus containing a single proton. Orbiting at a distance proportional to the size of the nucleus is an electron. The ratio of distances is roughly the same as the ratio of the Sun's size to the Earth's orbital distance. The hydrogen atom and the solar system have the same proportions. This is not because they are made of the same material or governed by the same forces. It is because they are both systems where a small, dense object is orbited by a much smaller object held in orbit by an attractive force. Similarly, consider the structure of galaxies. Galaxies contain billions of stars orbiting around a central black hole. The structure is similar to an atom, with a dense central object surrounded by orbiting bodies. The same pattern appears at vastly different scales. The same principles of gravity and orbital mechanics apply at both scales. This recursive structure suggests that there may be no privileged scale in the universe. There is no scale that is more fundamental than others. All scales are equally real. A quark is as real as a star. An electron is as real as a planet. An atom is as real as a galaxy. The universe is made of layers, and each layer is real and important. This has implications for how we understand ourselves. You are not made of fundamental particles. You are a pattern of atoms, which is a pattern of nuclei and electrons, which is a pattern of quarks and gluons, which is a pattern of quantum fields, but you are also a pattern of cells, which is a pattern of tissues, which is a pattern of organs, which is part of an organism, which is part of an ecosystem, which is part of the biosphere, which is part of the Earth, which is part of the solar system, which is part of the galaxy, which is part of the universe. You are not a thing, you are a process. You are a pattern of matter and energy that is temporarily organized in a way that creates the illusion of being a separate entity. You are a whirlpool in the river of existence. The water in the whirlpool is constantly changing, but the whirlpool persists. Similarly, the atoms in your body are constantly changing, but your pattern persists. This perspective transforms how we understand identity and persistence. You are not the same atoms today that you were a year ago. Most of the atoms in your body have been replaced, but you are still you because the pattern has persisted. The information, the memories, the structure has been maintained and copied as new atoms have been incorporated and old atoms have been removed. This suggests that identity is not a property of matter. Identity is a property of pattern. The same pattern can persist even as the material substrate changes. This applies not just to individuals, but to species, to cultures, to civilization itself. These are patterns that persist across time, even though the individual components, organisms, people, institutions are constantly changing. The poetic equation, where science becomes philosophy. There is an equation that stands at the intersection of science and poetry. It is perhaps the most famous equation in all of physics, yet it is also one of the most misunderstood. E equals m times c squared. Energy equals mass times the speed of light squared. This simple equation contains profound truths about the nature of reality. The equation tells us that mass and energy are equivalent. They are two forms of the same thing. A small amount of mass contains an enormous amount of energy. This is because the speed of light is very large, about 300,000 kilometers per second. When you square this number, you get an even larger number. So even a tiny amount of mass contains an enormous amount of energy. This explains why atomic weapons are so destructive. A nuclear bomb converts a tiny amount of mass into energy, according to this equation. The mass of a few kilograms of uranium or plutonium is converted into energy, releasing the force equivalent to thousands of tons of conventional explosive. The atoms are speaking in a language of ultimate power, but the equation has a deeper meaning. It tells us that matter is frozen energy. An atom is not a solid thing. It is a pattern of energy that has organized itself into a form that persists. The mass of an atom is essentially energy trapped in the bonds holding the atom together. The binding energy of the nucleus accounts for most of the mass of the nucleus. The electrons, with their kinetic energy and potential energy, account for the mass of the electrons. Matter is energy that has slowed down and solidified. In the first moments after the Big Bang, the universe was infinitely hot and infinitely dense. It was pure energy. As the universe expanded and cooled, energy organized itself into particles. Particles organized themselves into atoms. Atoms organized themselves into molecules. Molecules organized themselves into complex structures. Complexity emerged from simplicity. Order emerged from chaos. Consciousness emerged from matter. This is the fundamental transformation that has characterized the history of the universe. Energy has been organizing itself into increasingly complex forms. The universe has been creating structures of greater and greater sophistication. This process continues today. Stars are being born, planets are forming, life is evolving, consciousness is emerging. The universe is becoming increasingly complex. This process is driven by the second law of thermodynamics, the law of entropy. Entropy is a measure of disorder. The second law states that entropy always increases. In an isolated system, disorder always increases. Yet somehow, in the midst of this increasing disorder, pockets of increasing order are forming. Life is one such pocket. Consciousness is another. How is this possible? The answer is that while total entropy always increases, local entropy can decrease if energy is expelled from the system. Life maintains its order by constantly exchanging energy and matter with its environment. Plants absorb sunlight and use the energy to build complex molecules. Animals eat plants and use the energy to build complex bodies. The energy flows from the sun through life and eventually radiates away into space as heat. As energy flows through living systems, it creates order. The sun's energy drives the emergence of complexity. This is the poetic truth hidden within physics. The universe is not winding down into disorder. It is winding up into complexity. The energy from the sun is being captured and organized into increasingly sophisticated forms. Life is the universe's way of organizing energy into structures capable of awareness, capable of understanding, capable of reflecting on itself. The equation E equals m times c squared is not just a formula for calculating the energy released in nuclear reactions. It is a statement about the nature of reality. It is saying that the boundary between matter and energy is not as sharp as we ordinarily assume. They are two faces of the same coin. They are two languages for describing the same thing. One moment, energy. The next moment, matter. One moment, matter. The next moment, energy. The universe is constantly transforming between these two states. This has profound implications for how we understand consciousness. Consciousness is not separate from matter. Consciousness is not a mysterious, non-physical substance. Consciousness is what matter becomes when it organizes itself in a sufficiently complex way. Consciousness is matter becoming aware of itself. It is energy that has organized itself into a form capable of reflection. The atoms in your brain are not producing consciousness. They are not generating consciousness like a light bulb generates light. Rather, the atoms are organized in such a way that consciousness emerges. Consciousness is a property of the organization, not a property of the individual atoms. Just as wetness is a property of water but not a property of individual H2O molecules, consciousness is a property of neural organization but not a property of individual neurons. This perspective dissolves the mind-body problem, the ancient puzzle of how consciousness can arise from physical matter. There is no problem. Consciousness is not separate from matter. It is not a ghost in the machine. It is what organized matter becomes. It is the universe reflecting on itself through the organization of atoms into brains. The atoms are speaking in the language of poetry and mathematics simultaneously. They are creating beauty and complexity. They are creating consciousness and awareness. They are creating the conditions for the universe to understand itself. The equation E equals m times c squared is just one way of expressing this profound truth. There are others, in art, in music, in literature, in the silence between thoughts. The eternal echo, returning home to the cosmic conversation. We have journeyed through the invisible universe of atoms. We have discovered that atoms are not inert building blocks, but active participants in a cosmic conversation that has been ongoing for billions of years. We have learned that atoms are ancient, that they carry within them the memory of their origins in stellar furnaces. We have learned that atoms are connected to everything around them through invisible fields and forces. We have learned that atoms are the foundation of consciousness, the mechanism through which the universe becomes aware of itself. Now, we return to where we began. We return to this moment. We return to the recognition that the atoms in your body are speaking to you right now. They are communicating through sensation, through emotion, through thought. They are telling you about the world around you. They are telling you about your own nature. They are telling you that you are not separate from the universe. You are the universe experiencing itself from a particular perspective. The atoms in your brain are the same atoms that have been part of countless beings throughout history. They have been part of dinosaurs and ancient humans and great philosophers and great artists. They have been part of mountains and oceans and stars. They carry within them the memory of all these experiences. When you think a thought, you are thinking with atoms that have thought countless thoughts before. When you feel an emotion, you are feeling with atoms that have felt countless emotions before. This is not to say that you are not unique. Each arrangement of atoms is unique. The specific configuration of atoms in your brain right now has never existed before and will never exist again. Your consciousness is singular, unrepeatable, precious. Yet it is also universal. Your atoms are the same as every other atom of their type. Your consciousness, while unique in its specific configuration, is made of the same fundamental stuff as all consciousness. You are both individual and universal. You are both unique and eternal. The atoms are inviting you to listen. They are inviting you to hear their ancient song. They are inviting you to recognize that you are part of something much larger than yourself. You are part of the Earth. You are part of the solar system. You are part of the galaxy. You are part of the universe. You are part of the cosmos that has been evolving for billions of years and will continue to evolve for billions of years to come. When you return to stillness and silence, you are returning to the home of atoms. In silence, you can hear the atomic whisper more clearly. You can feel the vibrations of atoms in your body. You can sense the presence of atoms all around you. The silence is not empty. It is full of the hum of atomic activity, the song of atoms bonding and breaking apart, the eternal conversation that sustains all existence. The atoms are inviting you to participate in their conversation. You are not separate from this process. You are part of it. Your choices, your actions, your thoughts are all contributions to the ongoing cosmic dialogue. Every time you eat, you are incorporating atoms that were part of other beings into your body. Every time you breathe, you are incorporating atoms that were in the air into your body. Every time you move, you are rearranging the atoms in your body. You are constantly participating in the dance of atoms. Thank you for joining me on this journey into the secret language of matter. If this experience has brought you inner peace and wonder, I'd appreciate a like and subscription to the Relaxing Science channel. Your support helps us create more explorations like this. Also, let us know in the comments if you'd like to see more content exploring the connection between science and contemplation. Where are you listening from and what time is it there? Share your location and time with us below. This helps us understand the global community of people seeking to connect with the deeper mysteries of existence. We are all atoms speaking to each other across time and space. We are all part of the eternal cosmic conversation. The atoms will continue their dance long after you have finished listening to this recording. They will continue to bond and break apart. They will continue to transform and evolve. They will continue to be recycled through living and non-living systems. They will continue to carry the memory of the universe within them. And perhaps, in some future time, these same atoms will be part of other conscious beings, reflecting on the nature of reality, contemplating the mystery of existence. The whisper of atoms is eternal. It echoes through billions of years of cosmic history. It echoes in the structure of galaxies and the atoms in your brain. It echoes in the bonds between molecules and the connections between people. It echoes in the silence between thoughts and in the depths of meditation. The atoms are always speaking. We need only learn to listen. In the stillness of this moment, as you close your eyes and settle into rest, the atoms in your body continue their ancient conversation. They continue to vibrate at their preferred frequencies. They continue to exchange energy and information. They continue to maintain the delicate balance that allows you to breathe, to think, to feel, to be aware. They continue the work that they have been doing for billions of years. They continue the sacred task of organizing matter into forms capable of consciousness. As you drift towards sleep, let the atoms guide you. Let their ancient rhythm carry you into the realm of dreams. Let their vibrations become the soundtrack of your inner world. The atoms are singing you into rest. They are singing the song of the universe, the eternal echo of creation, the infinite recursion of matter becoming aware of itself. The the cosmic conversation that has no beginning and no end. This is the magic of the atom. This is the secret language of matter. This is the whisper that has been speaking since the universe began and will continue to speak as long as atoms exist. You are listening to the voice of creation itself. You are hearing the atoms speak. You are participating in the eternal cosmic conversation. Welcome home.